Dear students, I am N.K. Dikshit. I am today going to start a new chapter, that is continuity and differentiability for class 12th. So the basics of this chapter, that is the limits and continuity, you have already studied in class 11th. So I will continue it for class 12. So today we are going to discuss continuity of the function. So let us start the continuity of a function. So what is the continuity and what is its graphical meaning, we will study here. So to understand the continuity, first of all we are taking a function, that is a function fx is equals to 1 if the value of x is less than or equal to 0 and its value is 2 if x is greater than 0. Now we are going to draw the graph of this function. Now the value of the function is 1 if the value of x is less than or equal to 0, and if the value of x is greater than 0, then the value of the function is 2. So you can see the graph of this function here. On the y-axis, at x equal to 0, the value of the function is 1. So a point is on the y-axis, that is 0, 1, and on the left hand side of the y-axis, all the values of x are less than 0, so the value of the function is 1. So we are getting a straight line. It is shown by the blue line here. Now on the right side of y-axis, the value of the function is 2. You can see here. So if we want to draw the graph of this function, then it is not possible to draw the graph without lifting the pen. So the line is continuous from the left side of the y-axis up to y-axis, but on the right side of the y-axis, if we are moving, then we have to lift the pen. So there is a break in the graph. So this graph is not continuous at x equal to 0. So this type of function is called discontinuous function, and this function is discontinuous only on x equal to 0. On the left hand side of the x equal to 0, this function is continuous. On the right hand side of this of the x equal to 0 or y-axis, this function is again continuous, but only at x equal to 0 this function is not continuous. So this is a type of discontinuity. This function is discontinuous. So here we can see this function is defined at every point of the real number line. So function is defined on all the points, because on the left side of y-axis means on the left side, on the x-axis this function is defined as x equal to for any value of x, the value of the function is 1, and on the right hand side the value of the function is 2, and on y-axis means for x equal to 0 the value of function is 1. So this function is defined at every point on a real number 9. Here value of the function at x equal to 0 coincide with the left hand limit, but left and right hand limit do not coincide at x equal to 0. We have already studied the concept of limit in class 11th. So if anything is not clear, then you can see the lecture for class 11th, limits. So this function is discontinuous at x equal to 0. Now I am taking another function, that is fx equals to 1 if x is not equals to 0, and the value of the function is 2 if x equals to 0. Now here the function is continuous on the left hand side of y-axis as well as on the right hand side of y-axis, but on y-axis the value of the function is different. You can see if x is negative means it is not equals to 0, or x is positive means if it is greater than 0 then its value is 1, but when x is exactly equals to 0 then its value is 2. So the graph of this function, here also if we want to draw the graph of this function, then we can draw a straight line on the left hand side of y-axis and also on the right hand side of the x-axis, but on y-axis the value of the function is different, that is 2. So we cannot draw the graph of this function without lifting the pen. We have to lift our pen on y-axis. So there is a circle that shows the gap from left side of the y-axis and right side of the y-axis. Now discuss the continuity of this function. Here left and right hand limit of the function are equal at x equal to 0, but it is not equal to the value of the function at x equal to 0. So this function is also discontinuous. So if we want to define what is the continuity, so continuity at a point, a function f(x) is said to be continuous at x equal to c, where c belongs to the domain of f(x) if limit x tends to c, f(x) is equals to fc. Means left hand limit of the function and right hand limit of the function are equal, and both limits are equal to value of the function at given point. If all these three values are equal, then we can say at x equal to c the function is continuous, otherwise function is discontinuous. Now I am taking some problems. First one is prove that the function f(x) that is equals to f(x minus 3) is continuous at x equals to minus 3. So for minus 3, if we take the limit of the function, so check it. For left hand limit h tends to 0, f c minus h, we are checking the continuity at x equals to minus 3, so the value of c is minus 3, so we can write here limit h tends to 0 f minus 3 minus h. So the function is given here, place the value, so we are getting limit h tends to 0 5 times of minus 3 minus h minus 3. So its value is limit h tends to 0 minus 15 minus 5h minus 3. So it is limit h tends to 0 minus 18 minus 5h, it is equals to minus 18 because h tends to 0 here. So the left hand limit of the function is minus 18. Now we are finding the right hand limit. So limit h tends to 0 f minus 3 plus h, because on the right hand side the value is greater than minus 3. So putting the value in the function, it is limit h tends to 0 5 times minus 3 plus h minus 3, it is equals to limit h tends to 0 minus 15 plus 5h minus 3. So it is limit h tends to 0 minus 18 plus 5h, but h tends to 0, the value of the right hand limit is also minus 18. Now check the value of the function at given point. So the function is 5x minus 3. So value of this function at minus 3, place minus 3 in place of x. So 5 into minus 3, that is minus 15 minus 3, that is minus 18. Now you can see the left hand limit of the function is equals to right hand limit of the function, and it is also equals to the value of the function. These three values are equal, so we can say the given function is continuous at x equals to minus 3. So on this point the function is continuous because all these three values are equals to minus 18. Now I am taking another problem. We are going to discuss the continuity of the function f defined by fx is equals to x plus 2 if x is less than or equal to 1, and the value of this function is x minus 2 if x is greater than 1. Now first of all we will discuss the continuity by draw the graph. So you can see here the graph of the function is if x is less than or equal to 1, means from the left side of x-axis up to x equal to 1, the value of function we can get by this expression x plus 2. Means if x is minus 1, then the value of fx is minus 1 plus 2, that is 1 here. If x is 0, then the value of function is 0 plus 2, that is 2. And also for x equal to 1, the value of function is x plus 2, so 1 plus 2, that is 3. So this point is 1 comma 3. So this blue line shows the graph of the function when x is less than or equal to 1. And if the value of the function, value of the x is greater than 1, then we can draw the graph of the function by using this expression x minus 2. So for x equal to 2, the value of function will be 0. For x equal to 3, the value of the function will be 1. So this point will be 3 comma 1 lies on the graph. So this red line shows the graph for the function when x is greater than 1. Now check, if we want to draw the graph of this function, then we have to lift our pen. Now we can draw the graph of this function continuously from left side to x equal to 1, but if we want to draw the graph of this function on the left side of x equal to 1, then we have to lift our pen and start with this point and we can draw the graph. So on x equal to 1, this function is not continuous, so this function is also discontinuous function. Now we are going to solve this question by using limits. So first of all, find the left hand limit, that is limit h tends to 0 f1 minus h. On the left hand side it is 1 minus h. We are going to discuss the continuity of this function x at x equal to 1. So 1 minus h means this value is less than 1, so we can use the expression x plus 2. So limit h tends to 0 x 1 minus h plus 2, so its value is limit h tends to 0 3 minus h, so its value is 3. Now right hand limit is equals to limit h tends to 0 f1 plus h, it is equals to limit h tends to 0. Now see, for x is greater than 1, the function is x minus 2, so we can use 1 plus h minus 2 here. Then we get the value limit h tends to 0 h minus 1, because h tends to 0, so the value of right hand limit is minus 1. Now the value of the function f1, when x is equals to 1, then we can use the expression x plus 2, so 1 plus 2, that is 3. The left hand limit of the function is not equal to right hand limit, so we can say the function is not continuous at x equal to 1. So in this way we can discuss the continuity of a function, and we can check whether the function is continuous at given point or it is discontinuous. Now there is another problem. The function is fx is equals to 2x plus 3, and this expression is when x is less than or equal to 2, and we have to use the expression 2x minus 3, means the value of the function is 2x minus 3 if x is greater than 2. So find the points of discontinuity. So this question is for you. Practice this question. If any problem, then you may ask. Now I am going to discuss some more points related to continuity of a function at a given point. In these questions we have used the concept of limit. So once again I want to remind you what was the limit that you have studied in class 11 very briefly. A function at given point, we have to check whether the limit exists or not. Then limit of the function fx at x equals to a, then the left hand limit of the function can be found by limit x tends to a negative fx. Also we can write this as limit h tends to 0 f a minus h. We can use any one expression to represent the left hand limit. In NCERT book mostly this expression is given, but this expression is also very convenient. I am using this. Now the right hand limit it is limit x tends to a positive fx. Also we can use limit h tends to 0 f a plus h, and the value of the function at x equal to a, so it can be represented by f of a. Now function fx will be continuous function fx will be continuous at x equal to a if left hand limit is equals to right hand limit, and it is also equal to value of the function at x equal to a, means limit h tends to 0 f a minus h is equals to limit h tends to 0 f a plus h, it is equals to f a. Then we can say the function is continuous. Sometimes, now we will discuss the point in which condition function is discontinuous. So fx is discontinuous at a point x equals to a in following cases. The first one is fa is not defined if at that point the function is not defined. Second one is limit x tends to a fx does not exist if at that point limit of the function does not exist, then we can say the function is discontinuous. And third one is limit x tends to a fx is not equals to the value of the function, then also the function is discontinuous. But in third point, the discontinuity is called removable discontinuity. So how to remove this discontinuity we shall study in higher classes, so it is not the syllabus of class 12, so we will not discuss here. So to class 12th we will say that if the limit x tends to a fx is not equal to fa, then function is discontinuous. So in all these three conditions the function is discontinuous. Now I am going to discuss a problem which was asked in this year 2020 board exam. That was, question is, if fx is equals to, x is a function, its value is lambda x, if x is less than or equal to pi, and its value is cos x if the value of x is greater than pi, and this function is given continuous, then find the value of lambda. Problem is this. Find the value of lambda. You see the solution. This question was asked in this year 2020, 1 mark question. So we have already discussed that a function is continuous if left hand limit equals to right hand limit and also equals to value of the function. So first of all we are going to find left hand limit, that is limit h tends to 0. Now you can see the function is discussed at x equals to pi or greater than pi or less than pi. So we will find the limits on x equal to pi. So for the left hand limit h tends to 0, limit h tends to 0 f pi minus h. Now, pi minus h, that is the value less than pi. So when x is less than pi, the expression used is lambda x. So we can use it, limit h tends to 0 lambda times pi minus h. Now you can see h tends to 0, so its value is lambda times of pi. Now find the right hand limit. Now find the right hand limit. Limit h tends to 0 f pi plus h. So it is the value x is greater than pi, so we can use the function cos x. So limit h tends to 0 cos pi plus h. You know the value cos pi plus h is equals to minus cos h. And if h tends to 0 and cos 0 is 1, so its value is minus 1. Now, value of the function means what is the value of f pi. So check for x equal to pi, the expression is lambda x. So we can use lambda and the value of x is pi. Now the left hand limit is lambda into pi. Value of the function is also lambda into pi, and the right hand limit is minus 1. And this function is continuous. Function is continuous. Therefore, left hand limit is equals to right hand limit equals to value of the function 8 pi. So left hand limit is lambda into pi, right hand limit is minus 1, and value of the function is also lambda pi. So value of the lambda is minus 1 upon pi. So this is the answer. Now some more questions we will discuss later. Now try to solve the questions from your textbook and also from exemplar given by NCERT. Okay, thank you.